So let us look at example number 4. So this example is on equimolar counter diffusion. So the question is saying that ammonia gas, so we can label ammonia gas as A, is diffusing through a uniform tube 0.1 meter long containing nitrogen gas, and we label nitrogen as B. So we already have our component A and component B at 1.132 times 10 to the power of 5 Pascal. So this is our total pressure, and then at 298 Kelvin, this is our system temperature. At point number 1, okay, so PA1, which is the partial pressure of ammonia at point 1, is equal to 1.13 times 10 to the power of 4 Pascal. And at point number 2, PA2, the partial pressure of ammonia at point 2 is equal to 0.50 times 10 to the power of 4 Pascal. The diffusivity or diffusion coefficient, DAB, meaning that the diffusion coefficient of ammonia into nitrogen gas is equal to 0.23 times 10 to the power of negative 4 meter per second. Calculate the flux at steady state. Okay, calculate the flux JA at steady state and repeat for JB. And then here it is important, assume equimolar counter diffusion. Okay, so the question is already telling you assume it is equimolar counter diffusion. So automatically, once I have seen that it is equimolar counter diffusion, I can just write our NA is equal to JA. Okay, so the question is now asking me to find the value of JA and JB. So if we were to look at our general equation, we had that our NA is equal to, you can say, JA plus our convective term, which is CA over C, NA plus NB, right? So if this sentence was not here, assume equimolar counter diffusion, so you can still find the value of JA, right? But you need to know the value of NA, you need to know the value of NB, and then you have to rearrange the equation. But since there's this statement saying that assume, so I can just say that I already can find the value of JA. How? I can just find the value of NA. How do I find the value of NA? I already know that NA is equal to JA. So now, so that is the first step. Second step is that I know that all this information that I have here. So if I look at all the informations, I can write here my PA1 is known, PA2 is known, my ZT, the distance of diffusion is known 0.1, and then I know my temperature, right? I know my T of the system, I know my DAB, diffusion coefficient, I know, and then I can just find the value of R, which is constant. So based on this information, for me, it will be easier if I use the equation which has the value of partial pressure or mole fraction of gases. So I don't want to use the equation that has the term of concentration. So for me, it will be easier for me to use JA is equal to DAB over RT times, we can have here ZT, times PA1 minus PA2. Okay, so this is straightforward. I know the value of DAB, I know the value of ZT, I know the value of R, I know the value of T, and I know the value of pressure difference, PA1 and PA2. Now, substituting all the values, okay, so I will not substitute all the values. I'll just give you the final answer. You can go back and try to substitute all the values based on the information given here. And please, you must know how to select the correct value of R here. So it depends on what is the information that you have in terms of pressure, in terms of your ZT, so DAB, so temperature. So find the appropriate value of R. So you will get a value of around 4.7 times 10 to the power of -4 mole meter squared second. Okay, so this is my value of JA. Okay, so if you want to find the value of JB, right now we have to, the question is saying us calculate the flux of JA, flux of A at steady state, and repeat for B. So you have to find the value of JA and JB. So I already know that the value of JA is this one. So if we were to look at equimolar counter diffusion, right? So we already said that NA is equal to negative NB. Okay, this is only valid for equimolar counter diffusion. Whatever amount of A is being diffused, the same amount of B will be diffused, just in the opposite direction. So if you are asked to find the value of JB, you can just say that JB is actually equal to negative 4.7 times 10 to the power of -4 mole meter squared second. That's it. This is the value of JB because I'm using this relationship. But let's say you say that, oh, I'm not sure. How do I get this value? How can I be sure that I will get the same value, just the opposite sign? So we can just find the value of JB the same way we find the value of JA. So we can write JB is equal to DAB, DBA, okay, no longer DAB, right? Because now we are focusing on B. So DBA over ZT RT, and then here will be, it will be PB1 minus PB2. Okay, so the same thing here, instead of having B, I put A. Now the value of DBA, we already discussed in our previous class. DBA should be equal to DAB. DBA is equal to DAB. So we already know the value of DBA. ZT, we know because it will be diffusing using up the same length. So ZT will be the same as for ZT for JA. R will be still the same value because it's a constant, and T will be same because it's the temperature of the system. Now the issue here is that we need to find the value of PB1 and PB2. Okay, if let's say I were to draw the tube. Okay, so let's say this is 0.1, this is 0.2. Okay, and the distance between 0.1 and 0.2 was just saying that it was 0.1 meter. So at 0.1 we will have A and B, and at 0.2 we'll also have A and B. Okay, and we know that the total pressure of the system, P total here is equal to, I think it's 101,325 times to the power of 5 PA, and also the P total at 0.2, because we're saying that the pressure of the system. So at 0.1 is the same system at 0.2. So P total at 0.2 will also be 1.1325 10 to the power of 5 PA. Okay, so and then we also know that if we have our total pressure and we have component A and component B, we can say that PA1 plus PB1 must be equal to PT. This is pressure at point 1. And we can do the same thing for pressure at point 2. PA2 plus PB2 must be equal to P total. Okay, so based on our question, the question already gave us the value of PA1 and PA2. So if we were to find the value of PB1, will be equal to PT minus PA1. And then the same thing, if you want to find the value of PB2, is going to be PT minus PA2. So the value of PA1 was given to us as 1.013 10 to the power of 4 PA. Sorry, PA is our unit for Pascal, not pressure, okay? So if you have, it might be a bit confusing. I'll just write this one. The value is 1.13 times to the power of 4. And then our value of PA2 is given to us as 0.507 10 to the power of 4. So based on this relationship, we can actually find the value of PA1, PB1 and PB2. Once we have found the value of PB2, we can substitute into this equation and you should get this value again. Okay, so by right, you should get this value. If you are not getting this value, you are doing something wrong here. And remember, you must have the negative sign because of this relationship. NA is equal to negative NB. So either way, you will get this one is correct, this one is correct. Or if you just recalculate again, and then you'll get the value of JB is equal to negative 4.7 times 10 to the power of 4 mole per meter squared second. So this one is also correct if you calculate using this equation. So it depends whichever you are comfortable with.